Hi there, the Convergent Miniframe video got picked up and there was a lot of interest in it and some good suggestions on what to do with it. And people have been asking me, it's been weeks, have you got that thing fixed yet? And the good news is I actually did get it mostly fixed, at least fixed to the point where it boots. And not only that, but I got a second Miniframe. And the second Miniframe works correctly, so I can actually demo you a fully functional one as well as go through a bunch of diagnosis on the one that wasn't working right. Okay, so I met a user named Tom Trubisky online, and Tom, back in the day, developed some monitor ROMs for the Convergent Miniframe. Tom didn't have the CTIX operating system, but he did develop the monitor in ROM, and then he used it to read some of his own disk images. So I have taken, Tom was kind enough to give me his monitor, and I have burned it into a couple EEPROMs. So what we will do is we will pull out the original ROMs, we will put these EEPROMs in their place, then we will boot it up and hopefully we will actually have a serial console that we can actually use. And that'll be kind of nice. Okay, here we are at the debug monitor, Tom Trubisky's debug monitor. So this is what it prints when it starts up. It prints out a list of the registers. Now it's a typical debug monitor. You can do things like examine memory. So there, the memory at 3000. We could fill memory, 3100. It's just going to fill it with zeros, so it'll be zeros again. And you can set breakpoints, you can execute, you can jump to location, you can do all kinds of useful things with it. But what I'm going to do is to try to read a boot sector. I have constructed here a very special boot sector. This is the one that we're going to try to read, and I have written a pattern to it that I hope will illustrate our problem. Here we can see it has the original bytes, the 55, 51, 56, 51. That's the signature that it's looking for. But the rest of it, I've written this sequence of words starting at 3004 hex. And the reason I've chosen to do that is because this is where I expect it to show up in memory. So when it reads this in, the buffer in memory that it's going to read to is at 30000. So let's go ahead and try to do that. So I'm going to set a couple breakpoints. I'm going to set a breakpoint at 008036A. That is a breakpoint right after it has read the sector. And then I'm going to do a go 008002E2. This will execute the routine to read from the disk. So let's do that. And it executed it, it stopped at the breakpoint, and now we'll do a dump 3000 again. There's actually nothing there, which is interesting. Let's try going again. Look, we got one of them. 30F4 showed up, but it's the only one that showed up. Now, I know that this routine doesn't actually clear the buffer in between attempts, so if we go a couple more times, and then we do a 3000, we'll see a few other things have shown up. Like 303A is now there. And 300E is there, but that's in the wrong place. That should be up here on this row. 0FC showed up. It's actually in the right place, but well, there's two things that are interesting. The first is that not all the data is showing up. Only a couple of words are getting read each time. And the second thing I think that's interesting is showing up at the wrong place. So what I'm going to do now is I'm going to clear that breakpoint, and I'm going to set a new breakpoint for 0080037C. Now this will be triggered after it has detected that signature in the first 4 bytes. So it's going to execute many passes of this. I mean, we can see how slowly it's filling this thing up. It's going to execute many passes before we actually get to that pattern detected, but maybe by then we'll have a fuller buffer. So let me go again. Okay, we hit 37C, so it has actually detected the signature. And let's do a dump 3000 now. And let's take, oh my, see, things are all messed up. So at address 3004, we have the word 3024. That one is supposed to be down here. But down here we have 3034, and we've also got a 3034 up here. 3026, which should be down here, is actually up here. Some of them are right, like here's 3088, it's in the right place.
3088 is in the wrong place and also in the right place. These things are just all jumbled up. And the reason you're seeing duplicates is just because it probably had to execute many passes to load these up, and it's kind of permuting them around in the wrong places. But one thing that's interesting to note is that the sort of the lower bit is always right. So, this column here has all fours in it. It's just this next set of 4 bits is wrong. So it's like there's something wrong with the address register. So given what we know about the data going to the wrong lines in memory, I decided I would start looking at the schematic and identify what was responsible for those address lines. Now, some of the things I saw were these LS461s. This one here and this one here are the disk address counters, upper and lower address counters. They're responsible for those bits. So maybe there's something wrong with, bits 3, 4, or 5 in there in the address bus. If we have the refresh generator, another LS461, now it is touching exactly those bits where problems were going on. So I made the decision I would go and replace all of those LS461s.
So I went ahead and I desoldered 3 of the 74LS461 chips. It's this one, and this one. And then I put sockets in their place. So now I can put new chips in and we'll try it out and see if that repairs the issue, any of those 3 chips.
So here's what it looks like after replacing those LS461s. So this is loading the boot sector. Recall that this should just spew out numbers straight across. And previously we had that problem where they were kind of showing up in the wrong row. You would get this one would show up down there or something like that. But now everything is in the right row in memory, but we've got these weird holes that are occasionally appearing. So there's one hole. Here's another hole. Down here's 2 holes adjacent. And every time I run this, they show up in different places, sometimes more holes than others.
Okay, here I've got my logic analyzer hooked up to the board. I've got it hooked up to 2 different places. This I see up here is the lower word DMA buffer, and then down here is the bus arbitration. And I think over here, can't see it there, is the memory write line. And this is just a cheap knockoff logic analyzer. You can buy these things on eBay. They do like 16 lines. I really need to invest in a better one because I could really use like 24 or even 32 lines for something this complex. But I will use this to capture the logic transitions, and we will see whether data is actually coming out of that lower DMA buffer I see.
Okay, I made many different passes with the logic analyzer looking at various lines as I slowly narrowed down to where this latest problem was. And this is the last pass I made. So I wrote a little post-processor which would take the raw dump from the logic analyzer and output what's going on. In this column, you can see the bits that are on the data bus. So if 0A is there, then we were writing the 300A word. Previous iterations of this, I actually had all of the bus arbitration out so you could look at it, but I only have 16 lines available on the logic analyzer, so I had to drop those ones. I was looking at some other things, but the point where the memory access, where the write actually occurs, is right around here. So it asserts the write bit, it does some stuff with the RAS lines, with the data out there in the bus, and then it deasserts. So here you're seeing 300A's transfer, which succeeded, 300C, which failed, and then 300E, which succeeded again. And at this point, it was obvious what was going wrong. There's this line base mem, which tells the Miniframe where to send the data. Does it send it to the memory on the main board, or does it kick it out on the expansion connector? For the 2 good transfers, base mem is low. The data goes to the main board. But for the bad transfer, for some reason, it kicked those bytes out the expansion connector. Not only that, but it kicked them out with the address line 20 asserted, which meant that it was trying to write them at an address above 1 megabyte. The Miniframe doesn't even have more than 1 megabyte installed, so these bits were going nowhere, and that is why we ended up with holes in our memory. So then I ended up looking at what was responsible for that LA20 line that seemed to be going high during the disk transfers, and I came up with this programmable array logic right here. at 22F. Now, interestingly, these 461s were where I found the previous problems. And right here we are at the neighboring PAL, which is doing the upper address line. So I'm going to swap this one for a PAL out of the good Miniframe. Okay, let's go ahead and try to boot this thing using its original image on the MFM emulator. Now that we have the problem fixed, we'll see if it boots. I'm going to go turn on the power. I can actually see over here on the MFM emulator that it's seeking and reading disk blocks, so that is a good sign. There we go. Welcome. Miniframe CTIX. I believe we can just log in as plain ordinary root with no password. That's what the etc password file led us to believe. Welcome to Miniframe, mail not found. Okay, yeah, this is cool. We're actually logged in and running it. What do you want to do? There's not any games or anything. User bin. Oh, memory fault, core dump. That's not good. So yeah, we're getting some intermittent memory problems. So I would say we don't have this thing fixed after all, because it just crashed. It may actually be doing a reboot sequence now. I see the MFM emulator over here is blasting away. So I think what it'll do if something goes terribly wrong, it will right like it's a core dump into a special spot on the boot disk, and then it'll do a reboot. Okay, one more time. Let's see if we can get anywhere. Memory fault, core dump. So yeah, it could actually have some bad RAM chips. It could have another bad PAL. It's hard to know.
Okay, we managed to get it to boot, and we managed to log in, and we managed to run a few things, but we got a lot of core dumps. So something is obviously still wrong with this computer. I have replaced, throughout the course of this diagnosis, before I got out the logic analyzer, I was just going through replacing ICs in order that I suspected they were problematic. And I've replaced something like 60 ICs on this thing. I haven't replaced any of the RAM, but like all this stuff in here, all this stuff, anything that's not in a green socket, green sockets were original. Most of the things that are not in green sockets, I replaced them. So I have replaced every 74 LS 646, replaced all the 461s. I've replaced like 10 74 F74 flip-flops. I replaced all of the 74 F245 buffers. I've replaced 74 F373s and 244s and 74 F00s logic gates. Kind of run out of things to just keep randomly replacing. It's possible that the remaining problems are all in these PALs. But I think I'm going to take a break from this machine for a while because I'm tired of continuing to replace stuff in it. And we will move on to something else. But I do feel like we've had a measure of success. So I was talking about my buddy AJ back when I was diagnosing the broken Egyptian Miniframe, the one that I was having trouble getting going. And he showed me pictures of some Convergent Technologies hardware that he had located. This hardware happened to belong to Andrew Knutson, and Andrew had been a long-time Convergent employee. He had worked on CTIX as well as other systems at Convergent. He'd done a lot of networking work, it looked like, and he's gone on to have a long and distinguished career in the operating systems and systems field ever since. But anyway, Andrew had a couple of computers he wanted to get rid of, so AJ was talking to me about these. You know, what did I think about them? Did I think they seemed useful? What did I think they were? And I said, well, it looks like a Miniframe and a Mightyframe. Looks like it'd be useful and it'd be fun to play with. And then AJ says, well, that's great because they're in a van headed to your house. And lo and behold, the next day, this stuff showed up. So what we've got here is the one in the middle. That is a Convergent Miniframe. If you watched the previous video, you've already seen one Miniframe, the Egyptian one. This one we'll call the Knutson Miniframe. To the left of it is a Mightyframe. We'll get into that in a future video. And then to the right of it are two Convergent serial terminals that would have been used with the Miniframe or the Mightyframe. And then in a couple of boxes sitting to the side there are some keyboards, cables, power bricks to go with the terminals, etc. So let's take and flip this Miniframe around. Well, let's flip both of these around so we can get a look at the front of them. The Mightyframe, very heavy. It's going to take two of us to get these up to the office. That thing is, I swear you'd think it was made out of solid iron. But that is the front of a Mightyframe. See, drive in there, tape. The Miniframe, that's a little easier to deal with. This one does have a bunch of serial boards on it. Flip it around. Get a look. And there you go. You can tell that this is a slightly different one than the one I had shown previously, because it has the tape drive and it has a single half-height floppy. So we're going to drag this one upstairs to the office, crack it apart, look at it, and see if we have any better luck getting this one going. Okay, let's go ahead and we'll open up the Knudsen Miniframe. I already released the two catches on the top. In case you need to know how to open one of these, there's a couple slots. You just push down in the holes with a screwdriver and you can crack it open. Here we go. Much cleaner than the one that came from Egypt. Something I noticed was bouncing around inside of it when I carried it upstairs. And I'm thinking, ouch, these two hard drives, they're just kind of loose in here. They're not bolted down, so I'm hoping they made it all right. We'll hope so. Oh, look at all the aluminum corrosion on this thing. This looks like a drive that's been sitting around. Oh, hey, there's a note. Hi, Andy. Here's the 140. Don't be fooled by its exterior. Well, that's good. That's good because the exterior looked bad. It works. It's IV'd and ready to go for Miniframe only. It's from TS in 1986. The floppy cable goes up here to the floppy drive. There is no cable hooked up to the tape drive. So I would say, although this Miniframe has a tape drive in it, it does not have the tape controller. I'll get some top-down pictures in a bit. Okay, so here's a top-down view. Let's take a look at this one. This one actually has 3 board stack. There's the serial board. Then there are 2 memory boards in here. Each memory board having 512K. Much cleaner than the Egyptian Miniframe was. A lot less dust and dirt in it. If we pull this off, we can get a look down there at the main board. Taking you pull this back, and then you can lift right up. Oops. On this assembly, and there is our main board. Here's our stack. Whoa, careful. Our stack of expansion boards. Lucky I didn't break anything there. Now let's also have a quick look at the power supply. So everything about this power supply is heavier duty than the other one. So the capacitors, it's got huge capacitors down here. Some more in there. There's more stuff behind here. The fan, they moved the fan from over here on the smaller Miniframe to over here. These here are also bigger. You've got more wires, I think, coming out down here. Yeah, this looks like there's additional pins on this connector for the drives. This additional connector coming out the side for that drive. Just beefier all the way around. Okay, next I'm going to try out this terminal that also came from Andrew. So I have it connected to Andrew's Miniframe via the RS485, this little CT networking connector. So it is not connected via serial. It's connected through this sort of fast serial networking port. Now my assumption is when I turn this on, it's actually going to network boot this from that Miniframe. I'm running the Egyptian image at the moment, so let's turn it on. There we go. So those dots, I think, are loading an image. And there, it just booted. So it remote booted. It loaded some kind of an image. And look, we should be able to log in now. Cool. Log in as root. Yeah, here we are inside the Egyptian Miniframe image. User/bin. I wonder if, whoops, ls. Wonder if vi works. Whoa, what just happened? Huh. Oh. Yeah, okay, so this is a problem with the Egyptian Miniframe image. It's upset about something about its file system. So I really need to repair the file system, then maybe we could get it to work right. One of the problems is all of these file systems that I have dumped from the original hard drives are bad sectors someplace, problem somewhere. But let's see, user/bin. I do want to see if vi works over the terminal. Weird. Visual needs addressable cursor or upline capability. So yeah, maybe we don't have the right terminal type configured. Anyhow, this is dev tty020, and then what we will do is, well, it makes noise. Cool. Next, what we will do is I'm going to boot up the Andrew Knudsen's image that probably has source code and useful, interesting stuff on it. So we'll probably do that on the laptop so we can get a good screen capture of it.
Okay, let's try to boot up the Knudsen image on the Knudsen Miniframe. I'm going to go turn on the power. Do you want to boot anything other than the default? I'm going to say no for now, but maybe at some point we can try saying yes and see what happens. Is the date? Sure, why not? It's not like it's going to matter. Check the file system. I'm going to say no. So I did want to mention while this is booting here that if we do come across any personal data or anything like that, I'm careful with that. You know, we'll omit that, we'll delete it. Kernel debugger. So Andrew certainly was a developer, so he would have had a debugger loaded. I believe he worked on the networking stack. This Miniframe does not have Ethernet, though it does seem to be trying to load an Ethernet device. That's interesting. So we've had our first core dump. That could be due to the missing Ethernet device, could be something else that's wrong. When I imaged this drive, there were 30 bad blocks, so that will probably have an effect. Now, Andrew did mention to us that he had developed the SLIP driver, SLIP being an early networking protocol. So you can see it did try to load SLIP. It did actually try to talk to a network someplace. So maybe if we had a serial connection to a SLIP server, maybe we could have actually done something. Okay, there's no such thing as pure pleasure. Some anxiety always goes with it. Good to know. So yeah, here we are in the root file system. I've already poked around this a little bit, mounting it under Linux, but here we are on the actual thing. What directory? So we're in u/Andrew. So I know there is some source code sitting around here. Okay, certainly some source code. I'll have to poke around and see what all is here. What's in the README file? Oh, nice. So this is actually telling how to set up the environment. So let's go find some games. Why not? User games. What is in here? Advent. Oh, got the data. Save segmentation fault. That didn't work. Let's try it again. No, maybe we've got a corrupted disk block there. Maze. Nice. It generated a random maze for me. Could that be Star Trek? Yes, it could. What length game? I don't know. 5? 5. 1. Short. Easy. Foo? Alright, that is Star Trek. I've actually never played the command line Star Trek game. Can I just quit? Quit. No. Move! New game, your guess. 3? Bad guess? 7? I don't know. I'm not sure. Pick. 0C. Why not? Oh, Wump. Maybe we could hunt the Wumpus. Nah, we'll figure it out. There are tunnels. Move or shoot. Well, I'm going to shoot. I'll shoot at 6, 9, and 17. Why not? Okay, that didn't accomplish anything. Move to room 9. Move to room 17. I fell into a pit. Oh, bummer. Hangman. Sure, I can pull that one off. Yes. Nope. Do I have to type a letter? S T. Ah, it starts with T. E. How about an H? The M R. Therefore, I bet it's therefore. F. Ah, therefore. There we go.
Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.